All right, so in this video, we're just going to go through a bit of theory for 3A, which is irrational numbers, including surds. So the learning intentions are written there, and we might just quickly skip through because I think it's important to get to, I mean, you can read most of that, but it's important to look at this number line and where numbers fit and what makes a rational number and an irrational number. So here we've got the -3. Okay, it's a rational number because it has a finite number of decimal places. Okay, it actually has -3 is an integer. Now, -1/2 is a rational number because it's 0.5 or -0.5. Okay, so it doesn't keep going. Your decimal places don't keep going forever. It can be expressed as a fraction. Now, the square root of 2 can't be. So if we put the square root of 2 into our calculator, the number of decimal places will keep going, and we can't represent it as a fraction. So we call that irrational. And pi, something that you might be familiar with, is also irrational. All right, so I'm going to just scroll through to the key ideas. Now, it's important that you put these key ideas into your bound reference. Okay, so I'm just going to read through these points, but you need to put them in your bound reference. So all real numbers can be located as a point on a number line. What it means by real numbers is we can have real or imaginary numbers. And I'm not telling a joke here. If you go on to do higher mathematics, like specialist maths at in year 12, year 11 and 12, you'll come across imaginary numbers. So that just means the square root of -1 we define as an imaginary number. But in year 10, we just need to deal with real numbers. So real numbers can include rational numbers, so numbers that can be expressed as fractions. Okay, so you can see there are a few examples. The decimal representation of a rational number is either a terminating or recurring decimal, and irrational numbers, numbers that it cannot be expressed as a fraction. So, for example, the square root of 3, -2 root 7, root 12, -1, pi, 2 pi minus 3. They're all irrational numbers. So the decimal representation of an irrational number is an infinite, non-recurring decimal. So it keeps going on forever. And non-recurring means that so like 1/3, if we were to represent it as a decimal, it would be 0.33333. So that means it's recurring. So it can't be a non-recurring decimal. So that just means there's no pattern to it. Surds are irrational numbers that use a root sign, so this square root sign, and there's a few examples there. These numbers are not surds. Okay, so the square root of 4 becomes 2. The cubed root of 125 is 5. The -4th root of 16 is -2. So this just means 2 times 2 is 4. 5 times 5 times 5 is 125. -2 times -2 times -2. Oh, sorry. 2 times 2 times 2 times 2 is 16, but we've got a negative sign there, so it becomes -2. The nth root of a number x is written. Okay, so with the n just says, okay, this is the square root, this is the cube root, this is the 4th root. Okay, so we covered this when we did indices. Okay, so we're kind of just looking at the reverse now. And the following rules apply to surds. So the square root of x all squared is equal to x, because the square root sign and the squared sign are basically the inverse of each other. So we're just left with x, so they cancel each other out basically. The square root of x is cancels out the squared number equals x, and that's for when x is greater than or equal to 0. The square root of xy, so inside the square root sign we just have xy. That means x times y, and you can actually separate them. So instead of having the square root of xy, you can have the square root of x times the square root of y. And then if you have a fraction, okay, they can be separated as well. When a factor of a number is a perfect square, we call that factor a square factor. So all these numbers are square factors and they keep going. Okay, so the square factors are just made up by multiplying a number by itself. So 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9. Did I say 2 times 2 is 2? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. When simplifying surds, look for square factors of the number under the square root sign and then use this. Okay, so in a video that I just created before this one, but you might watch it after this video, we actually simplify using that rule. All right, so this is just going through a bit of terminology. I'm going to just skip because I wanted to show you, and there's examples there for you to use. I'm going to skip. Oh, my son's getting a bit excited. Okay, you probably can't hear him. So, there's just a few questions I'm going to do together, but I think you'll be fine after watching the other video to move on for question 4. So, express each number as a decimal and decide if they are rational or irrational, then locate all the numbers on the same number line. So, I'm just going to get my calculator up. Do I have my calculator in here? Oh, my calculator played up before, so I might just pause this and get my calculator up. Okay, sorry, my calculator's just playing up. There we go. It decides to open when I start playing the video again. All right, negative square root of 2. So on your calculator, you've got a negative sign and a minus sign. So make sure you choose that. Otherwise, it's not going to like the minus sign, and it will tell you. Okay, the square root sign is just here next to the 4, but you need to press Control first because, as you can see, it's in blue. So the square root of 2. Okay, so you can see there's decimal values. It's not recurring. Okay, so negative root 2 is a surd. What's the next one? 150%. Let's just do 6 over 7. Sorry, I'm skipping. 6 divided by 7. Okay, so you can see there also not a recurring decimal. Okay, so you can see a recurring just means you've got a pattern. So 857,142, 847,114, and it's going to keep going. But we've also got a fraction here. So remember, a fraction is not a irrational number. Okay, and then 150% is not irrational either. Express each number as a decimal and decide if it's rational or irrational, then locate all the numbers on the number line. I think you'll be able to do that. Question 3. Now, if you haven't already watched the video, and I'll just say what I'm talking about, which was that, where we did that, probably go ahead and do that first. So the video is called Simplifying Surds. Go and do that before you start watching what am I doing? Sorry. Do that before doing question 3. Okay, it will help you identify what a surd is. It will actually also teach you how to simplify a surd. Okay, and then question 5 is also simplifying surds, but this time you've got to think about the number at the front. So the square root of 18, when you simplify it, becomes 3 root 2. So it's going to be 2 times 3 root 2, so 6 root 2. So you're just basically multiplying it by another number, nothing too different. And then you got some fractions there, so remember the rule. So I might just write that down. This becomes, sorry, I just remembered the computer my pen doesn't like Adobe. Let's do it on here. Okay, it's just got a blank spot here. So the square root, let's do it again. Square root of 8 over 9, you can separate to become the square root of 8 over the square root of 9. Now the square root of 8 simplifies to 4 times 2. The square root of 9 is 3, and that becomes 2 root 2 over 3. So if you're not understanding what I've done here, watch the other video on simplifying surds before you tackle 4A. Okay, and I might select a few difficult ones to do in a video, But if you get to do this and you find some difficult ones first, please let me know and I'll make sure I include them in the video. Okay, bye.